Welcome to another Git instructional video. My name's Dan, and today we're going to talk a little bit about branching in Git. So let's go ahead and get started. The first thing I want to show you today is a little image that I drew up in about 10 seconds. That's sort of a visual representation of how branching works in Git, and it's very similar to other source control management tools that do branching. But basically, I just want to give you a visual of this before I get into the technical details so that you can kind of visualize what happens when I'm actually doing it. So this is the simplest representation of what branching might look like, where each circle here is a commit, and the first commit is at the bottom. You can think of this as, the inception of the repository. And then in this example, some commits are made and a branch is created at the point of the fourth commit. So this vertical line is supposed to represent the master branch, and a branch is made at the fourth commit called feature 1. So a feature branch is created. 3 commits are made on the feature branch, and then the feature branch is merged back into the master branch via a git merge. And that's sort of what this line represents here. It's the merge of a branch back in to another branch. And so it's important to note here that in this visual representation, you can see 3 commits happened on the feature branch, but 3 commits also happened on the master branch that the feature branch never got. And so this merge point represents the synchronization of the branches, if you will. So anyway, I just wanted to visually represent this because we're about to do something kind of similar to this, and I want to keep this picture in your head because this is sort of important in understanding how branches work. Okay, so today we're going to use this Hello World repo that I've used in some of my other videos, and really there's only a handful of files in here, and just as a recall, there's a make file, and when it builds it simply prints some output. The CPP file is very simple. We create some instances of a fake box class. It doesn't really do anything except report what's contained within that class. So what we're going to do right now is create a new branch. As you can see, Git branch shows that we're on the master branch, and one way to create a new branch is to do git checkout-b and then the branch name that you want. So let's just call it feature 1. How about? Switch to new branch feature 1. So now if we do git branch, you'll notice we have 2 branches. We're on the feature 1 branch because we switched from the master branch, and you can tell we're on it because of this asterisk here, which shows which one we're on. But we just created the branch and we haven't made any commits, so technically, feature 1 is at the exact same point as the master branch. And you can prove that to yourself by doing git log on our current branch, and we are at F731. And if you do git log on master branch, we will see the same thing, F731. So I guess what I'm trying to point out there is that you can create a branch that may be at the state that another branch already exists, but until you actually make commits on that branch, it's not really a parallel line of development. So we're going to go ahead and create some commits. So we're just going to modify the CPP file. Let's create a box 3, and we'll just do another output. This is where you do actual development, but here I'm just trying to show you the mechanisms of branching. So let's make sure that it builds. Let's make sure that it runs, which is okay. It's a good thing to do as you're developing. So we're going to do a git add, and a git commit, and I'm going to just do a shortcut, added box 3. Okay, so git status shows that we're clean, git log shows that we have a new commit, added box 3, commit 1e5f. So we're going to do this one more time. I want to create 2 commits on this branch, and to follow my example, I'll make a 4th box and do the same mechanism here. Write the file, make sure it runs, and we see box 4 output. Okay, so we're going to go ahead and do the same thing. Add the change to the index, commit the change, dated with box 4. Okay, so now our git log will show that we have 2 new commits, adding box 3, and the one we just did, adding box 4. So what I want to show you, which is super cool about Git, is that this branching mechanism is designed to help you do your job more effectively. And so what's cool is you can have as many branches as you want. These branches are local. You don't have to have any connection to a centralized repository to branch off, try a feature. Maybe you don't like it, maybe you do like it. If you do like it, you might want to merge it into master like we showed in that image before. But you can also decide that you don't like it. So you could say maybe this is some prototyping work and we don't really care about it. You can just delete the whole branch. And the way you do that is with git branch -d and then the name of the branch you want to delete. So in this case, let's say those 2 commits we made, we didn't really like the outcome of that. And yeah, it's not real development, right? I'm just adding some code so that we can commit it. So it's not exactly a perfect use case, but let's pretend like that was some real work. We're adding a feature, and at the end, we didn't like the result, and we say, you know what, let's scrap the whole thing. We don't need this branch anymore. So this is what I wanted to show you. This git branch -d, and say, you cannot delete the branch which you are currently on, which it's not the error I wanted to show you, but let's go ahead and get rid of that. So let's try it now. We're on the master branch now. Let's try to delete the feature branch. This is the error I wanted to show you. So it's saying error, the branch feature 1 is not fully merged. If you are sure you want to delete it, run git branch -d feature 1. So what this is telling you is Git saying, hey, I see you've done some work on this branch. This work has not been merged into any other branch, which means there's 2 commits there that if we were to delete this branch would be lost. Are you sure you want to delete it, is all it's saying. So if you're sure, you can just give it the capital D, which is almost like the exclamation point D, like, yes, I really want to delete it. And we can do that. And it says deleted branch feature 1, which was at this head commit successfully. And so now if we do git branch, we'll see that we're on the master branch, and our git log shows F731, which is, 2 commits back from where the feature 1 branch was. And now if we do make and run, we notice there's only 2 boxes, right? That makes sense. We went back to the point in history because we changed branches and we deleted the branch that we did that work on. So we're back exactly to where we were at the start of this video. So another thing I want to show you about branching is the concept of tracking branches. And so tracking branches, let me sip of coffee here, hold on. That's good stuff. So tracking branches are you can think of them as branches that track your remotes. So if you're unfamiliar with remotes, I encourage you to watch some of my earlier videos. But basically, I've set up here a remote, which I've named UpDog. Git remote show UpDog this is just showing that I have a remote that I named UpDog, and it points to another repo, which is actually Hello2 alongside this repo. So I just wanted to create a remote to show you the concept of tracking branches. And so if we look at Git branch and we give it the -a command, which is sort of, show me all branches, we'll see that we have a master branch, but we also have in red here, this is a remote branch. So what we want to do, and you can think of these aren't real branches. This is really just saying when you do a git fetch, this is what gets updated. This is saying my local repo hello thinks that the remote UpDog's master branch is at the commit specified by that ref. So in that case, it's the same commit that we're on. And so I said that very specifically because if you haven't seen my other videos, it's really important to understand how these remotes work, how Git fetch updates them, and what this notation means. So I just wanted to point out that this isn't really a local branch, which is why that it's hidden by default, and you have to give it the -a to see it. But what we want to do here is we want to say, hey, we're collaborating with this UpDog person, and we want to be able to see their master. So we're going to set our master to be tracking the remote tracking branch UpDog master. And here's how you do it. Git branch u. So real quick, this will apply to the branch that you're currently on. So since we're on master, we want to apply a remote tracking branch to this branch. So we do git branch -u, and then the remote tracking branch that you care about. And so we just give it that, and Git tells you the branch master has been set up to track the remote branch master from UpDog, which is exactly what we wanted. So now if we do git status, you'll notice that we get a slightly different message. In addition to the on branch master, which we had before, we now have remote tracking branch information. It says, hey, we're up to date with UpDog master. Nothing to commit, working directory clean. So let's go ahead and make a couple more commits like we did before. And I'm just going to do something similar to what we did before. Let's open hello CPP. We'll add, just to distinguish from what we did before, box A. Call this box A. Box A, save the file, run the file, make sure that it works. Box A is printing out here. And status, add the change to the index, quickly commit the change, added box A. And we'll do the same thing for a box B real quickly. Oops. Git status shows the change again, add it to the index, commit it, added box B. Okay. So now, of course, if we look at our Git log, we'll see these two commits that we just made. We're still on the master branch. And if we do git status now, check this out. Because we set up UpDog master to be a remote tracking branch of our local master, git status tells us some information regarding our state compared to that state. It says your branch is ahead of UpDog master by 2 commits. And it's telling you some options here. In this case, we don't really care about Git pushing this stuff. So let's switch over to the UpDog remote repo, and we're going to use this. So we're in a totally different repo now. We'll pretend this is the UpDog remote, and we're just going to pretend to be another developer and do some work and create our own commits. So it's a brand new, fresh repo. There's nothing here. So, of course, if we look at hello CPP, it's back to the state it was before because we switched repos. So let's just call this box F, and we'll add a box F, make sure it works. It does. We're going to add it to the index and commit. Added box F. Okay, so we created this one commit, this other repo. And the reason I wanted to do this was for a couple reasons. One, if we switch back to the other repo, you'll notice that git status shows the same message, right? But you might be a little confused if you're new to Git. We just switched, quote unquote, to the updog side and made a commit. Why does it say that we're ahead by 2 commits but give us no information about the commit that was just made? And that's what I was talking about before. That's because this message is showing you information based on the last time you did a git fetch in your repo. Which means if we do git fetch updog and git status, remember git fetch doesn't actually change any of your files. We'll notice this this message saying that our branches have diverged. So I have 2 and updog has 1 different commits, and it's just giving some how you can git pull to merge with them if you want to do that. So what I want to show here is this is sort of, we've simulated the idea of 2 people working in the same repo. You know, Dan using the hello repo, this mystery updog person using the hello2 repo. And something that happens commonly in software development is, I'm working on my master branch. I made 2 commits. Meanwhile, updog made 1 commit. Let's say I get an email from updog. And updog tells me, hey, I have a problem. I need you to help me track this down. And it's in my current state of my master branch, which, from our perspective, is updog master. So if you're new to Git, and this trips people up commonly, I didn't understand this at first because most of the time developers are introduced to the concept of pull. Your initial reaction would be, oh, let me pull your branch and try to replicate it. But you don't want to do that because a pull implies a merge, right? So because we have 2 commits ahead of what updog master has, if we do a git pull like it says right here, yes, we will get updog master's changes, but it will be the merged state of updog master and our state. So what that means is, and this is a nuance here, if the problem that updog has on their master branch only exists at that precise commit, then we could merge with it and not see that problem. So what I'm getting at here is a lot of times you want to create a local branch at the exact location of another person's branch. And you don't want to do that with git pull. What you want to do instead is create the branch at that location. And so that's what I'm trying to express here, is that when you type git checkout-b, my new branch, whatever you want to call it, that branch is going to be created at the current head. And the current head is the top of your git log. So if we were to create a new branch here, then that wouldn't make sense, right? Because updog's work started from back here. So if we create a new branch here and then merge his changes or pull his changes, we're going to get his merged with ours. We don't want that. So the best way to do that is to simply check out to that exact ref, right? So we did a git fetch earlier, so we know, updog called us and said, hey, I need you to track down something on my branch. We do a git fetch to make sure we have his latest refs, and then we check out to that exact state. And Git tells you that you're in a detached head state, which we expect because this is a ref, not a real branch. And it says, hey, if you want to create a branch, then here's how you do it. So, you might be able to just poke around here and see the files and see the problem, build, track it down, use GDB, valgrind, whatever you need to do in a detached head state, which is what git status is showing. But if you need to actually make commits in this investigation, you're going to want to create a branch here. And so basically you want to do what it says right here. And what I like to do is to name it something that makes sense. So you can call it, a good name might be Updog Master. A better name might be Updog Master Issue Investigation, you know, if you're going to make commits on it. So let's just call it that. And so now if I do git branch, you'll see that we now have two local branches. The Updog Master Issue Investigation, which is exactly at the Updog Master ref because we just created it, and our local master branch, which we were doing some work on. So let's go ahead and pretend that we're actually tracking this down and we want to create a commit. So, you know, this doesn't make a whole lot of sense, but as an example, let's say, oh, it's box F is broken. Let's call it box G, which if you know anything about C++ makes absolutely no sense. But I just want to create a commit here. Git add u, git commit. Fixed box F issue by replacing with box G. So that simulates sort of a fix on this branch. And now our branch has this fix. So getting near the end of the video here, I just want to show you how easy it is to create branches, delete branches, manipulate branches. You want to move to a different branch, git checkout to it. Instantly, we're there, right? And it tells you the information. You want to switch branches, you check out here. So what's cool about Git is, you know, every time I do this git checkout operation, it's actually changing the working files in my tree, right? So that hello.cpp, every time I switch branches, is changing because there's differences between those branches. And so what's cool about Git is that you shouldn't ever have to have more than one repo. And there's exceptions to that. But in general, you know, you have a well-architected software project. You can switch between branches in less than a second. If you learn how to use the tool correctly, you can basically have a single repo and an infinite number of development lines, fixes, investigations. It's really a cool mechanism that, you know, I like to say that Git is the only source control management tool I've ever used that actually helps me do development. Every other one seems like it's just standing in the way. Real quick, the last thing I want to do is show you a cool tool that helps you visualize this stuff. But in order to do that effectively, I'm going to need to create a couple more commits just so I can visually show you what I'm trying to do here. So I switched to the master branch. I'm going to go into hello CPP and make another change. We're going to add box D. Write the file, add it to the index, commit quickly, added box D. Yay! And we're going to do the same thing real quick because I want to create two commits to show you this. Box E. You should probably be making this. Let's make sure it runs. Okay, runs perfectly. Git add u. We have it in our index. Git commit. Added box E. Okay. So the reason I did this is because I want to show you what two development lines look like. And you remember that picture that I showed you in the beginning of this video where they sort of fork off? Let's just bring it up. How about? is that called? Branching. Boom. Okay. Remember this picture? There's a tool called GetK that can show this, how branches are formed graphically, and it actually shows a lot of other cool information. So if you don't have GetK, you can get it through apt-get or yum install, depending on the platform. And when you bring up GetK by default, it's really just showing you information related to your current branch. So in this case, we're on master. We see a linear development from the root commit all the way up, because it's only showing information about our master branch. I'll do another video where I cover some of this stuff in more detail. But what I want to show you is that if you launch it with this option -- all, it will show you information for all branches. And this will give you a view very similar to what I was showing you in the image, that graphically you can see how branches are formed. So here we can see that updog master was branched off this commit, and we made a commit on top of that. Remember the fix on this updog master issue investigation. And if there were, we only made one commit, maybe we'd make 10, and you'd see 10 commits come up linearly alongside the master branch, which is happening on the left here. So I just wanted to show you that the graphical representation I showed you in the beginning is useful to visualize how this stuff works, especially when you have, here it's kind of easy. We have 2 branches effectively, but in big software projects, there can be dozens of branches and they can get merged into each other, and keeping track of where everything is can be overwhelming for a Git newbie. So I just want to show you this tool because it can be pretty helpful for trying to visualize this stuff. And you can actually see, if you click on each one of these, it'll show you a summary of what was changed. It's pretty useful, actually. I'm not big on GUI tools, and this one has some drawbacks, but if you're new to Git, try it out on, I think it's a Linux only tool. If you're on Windows, I feel bad for you. I'm so sorry. I think that's it for this video, guys. Thanks for tuning in. Just a real quick recap. To create a new branch, git checkout -b, new branch name. To switch branches, git checkout branch name. And to set a remote tracking branch, git branch -u, remote/branch. My name's Dan, and I'll see you next time.